Welcome to One Concept Per Day portal, and today's concept is about the Bohr cell. So, if you remember, yesterday we discussed about the hydrogen alpha scattering spectra, and we looked at how the alpha scattering can be understood with the help of the basic concepts like conservation of momentum or conservation of energy, then vector diagrams, vector addition, okay, and collisions. And now, but this concept, especially the hydrogen atom, is not one such one wherein you need to understand everything only if you have a basics of the quasi-quantum mechanics or quasi-classical mechanics, which comes in the Bohr's model. Okay, now let us understand or let us start solving the problem here. So, if you start solving this problem, probably I think you would have probably understood the complete Bohr's atomic model. Okay. So the first question goes like this. In 1913, Niels Bohr published his theory of the hydrogen atom, in which he proposed that an electron orbited a proton as illustrated in the diagram below. So there is an electron which is revolving around a proton. The velocity is of the electron is being shown over here, which is v. It's moving in a circular path, right? And then the two theories which include two postulates are known as Bohr's postulates. And if the radius of the orbit is r, then its orbital speed is v. The first Bohr's postulate can be mathematically expressed as mvr equal to nh by 2 pi. What is this postulate? This is your quantization of angular momentum. Okay, if you remember, this is your quantization. This is your first principle of Bohr, quantization of angular momentum. So, which tells us that the angular momentum cannot exist in any continuous manner, but instead it is seen to be discrete in nature, and for every orbit you see that it has a different angular momentum, and this angular momentum goes in terms of the multiples of h by 2 pi. That is what is called the first principle of Bohr's postulate. Okay, so which means that if you have a nucleus, I'll write it over here. If I have a proton here and an electron here, I write only one proton and electron over here. So this electron will have an angular momentum is equal to h by 2 pi because the first orbit. If I have an electron which is present in the second orbit revolving like this over here, then this will have an angular momentum equal to 2 times h by 2 pi. Why 2 times? The reason is because this is your second orbit. This is your second orbit. This is your second orbit. If I have the third electron which is revolving around like this over here, then this will have an angular momentum is equal to 3 times h by 2 pi. Okay. So this is what he proposed, that the angular momentum is always equal to multiple of h by 2 pi. Okay. Now let us move on. So according to this postulate, electrons can move only in orbits defined by n equal to 1, 2, 3, etc. Bohr called these allowed orbits as stable orbits. So he suggested that the electrons cannot move in between the first and second orbit. It can move only in first orbit, or it can move in second orbit, it can move in third orbit, and so on. It cannot move anywhere in between the space. Why did he suggest it? The reason is because according to Maxwell's electrodynamic theory, it was told that if at all an electron accelerates, okay, then it will lose energy. It will radiate energy. What do you mean by that? Means when a particle is moving in a circular path, definitely it has to accelerate. Why accelerate? Even if it is moving with a uniform velocity, uniform speed, why should it accelerate? If you ask me this question, we know that whenever a particle is moving in a curved path or in a circular path, it has an acceleration due to change in direction. That acceleration is called as centripetal acceleration. Centripetal acceleration, which will be equal to v square divided by r. So definitely this will never become zero. Even the v is constant, the centripetal acceleration will exist. And according to electrodynamic theory, definitely the electron will move and fall into the protons. That means no matter is stable. But we observe that most of the matter is stable. So therefore he suggested that there are certain special orbits in an atom known as stationary orbit. In these orbits, if the electrons are orbiting, then it does not radiate energy. Wow, that's a great thing, right? Okay, so therefore, he said the electrons which I am saying will never radiate energy even if it moves in circular orbit. But okay, it is moving in a stationary part. It is like saying, for example, okay, you should not observe shots or YouTube shots or Instagram shots, but still, okay, I can always say as a student that I will be able to, I can observe shots, okay, provided that whatever shots I am observing there, whatever shots I am viewing there, all these are related to physics, chemistry, and math. It does not relate to anything outward from it. So therefore, it is always helping me out in my exams. So I claim like this. So this is what has been done here also. Now let us come back to it. So according to this postulate, the electrons can orbit like this. Bohr called these allowed orbits stable orbits. Explain why Bohr called these allowed stable orbits and explain why such orbits are in contradiction to classical electromagnetic theory. Now what you need to do, you need to write the story behind it. What is the story? So why it is contradicting this? According to first one, classical electromagnetic theory, what did you have? You said that the electrons accelerating accelerated electrons accelerating radiate energy. Therefore electrons moving in a circular path will never be stable, will never make an atom stable. This is the first thing. This according to this is according to electromagnetic theory of Maxwell. Then second mark. Now if these electrons move in what kind of orbit? Yes, I told you, in allowed stable orbits. In allowed orbits known as stable orbits, they will not radiate energy. This contradicts Maxwell's theory. The same story what I told you, you are going to write it, okay, in this manner. Okay, next. The second Bohr's postulate may be stated mathematically as shown: En2 minus En1 is equal to Hf. Okay, let me explain you what is second Bohr's postulate. So he said that, okay, this is my, okay, let me go back to the figure over here. So this is my first orbit, this is my second orbit, this is my third orbit. Now the question is, how will an electron jump from first orbit to second orbit? Like, okay, you have balcony, you have ground floor, you have balcony, first floor, second floor, and so on. Okay, how do you jump? How do you make an object throw from or go from the ground floor to the first floor? So that means you need to provide some energy. You are providing some energy to the electron jumps over here. Okay. Sometimes these states, that is the second orbit, third orbit, excited states, what you call, these states are also called as metastable states. Okay, the name itself says metastable. That means not completely stable. Okay, it will be not completely stable. So it releases the electron, it makes us the electron, or it forces the electron to jump from this state to this state. Okay, so let me call this energy state. The energy of the electron in this state is, let us say, En2, and this electron energy is En1. This one could be En3, and so on. So after some time, this will jump back here. It says, array, you cannot stay here, you better go down to your native house or maybe your ground floor. When it jumps over here, see, it has to release a photon. Why should it release a photon? The reason is because, see, how did it jump? It jumped because it absorbs some energy. Who gave that energy? Okay, you gave it with the help of radiation, or maybe a photon mass. Photon's energy was transferred to it, and as a result of it, okay, the electron jumped from here to here. Okay, this is what you call as absorption of an energy. Okay, and that's where you study about absorption spectra in your electromagnetic, in your first part of your electromagnetic spectrum. And then when it jumps over here, what happens? There is a photon, whatever you have observed, it just gives back over here. So therefore, this is a photon being emitted. The frequency of this photon is given by Hf, okay, or the energy of the photon that comes out from here is given by difference in the energy levels. What is the difference in the energy levels? En2 minus En1. Why En2 minus En1? Why En1 minus En2? The reason is because this is at a higher energy level, this is at a lower energy level. Okay, strictly speaking, this has a lower energy level, this has a higher energy level. Okay, because we have a negative one, so we can claim it like that. Now let me go back and read the question. I told you about what is this Bohr's postulate doing here. Explain with reference to the term N used in the first postulate the following terms. What does it tell you? What is En2? You have to say the energy of the electron in the orbit n2. En1, same definition, energy of the orbit electron in the orbit n1. What is frequency? Frequency, F is nothing but frequency of the photon emitted when an electron jumps from n2 to n1. Let's write like this. Okay, now we have seen this also. Using both the postulates, Bohr was able to derive the Rydberg equation. Okay, fine. So there is some equation he has proposed. Don't worry, you have not studied this. Okay, but it doesn't matter, but he has already given you the equation. These kinds of questions can be asked. Okay, the equation may be written as shown. When n equal to 2, the equation enables the value of the wavelengths in the Balmer spectra series to be determined. Balmer spectra, you would have learned about this. Balmer spectra is nothing but the wavelengths of lines that are seen, the visible spectra. Okay, now you have not derived this equation, but so you have not got this value of lambda h over here, but you would have seen some equation like this over here. Okay, now if RH is equal to so much, determine the value of the longest wavelength produced in the Balmer series. Okay, now since he has given n equal to 2, now let me write down, which means that 1 by lambda can be written as RH into 1 by 2 square, which is 1 by 4 minus 1 by m square. 1 is 1 by m square. Now you observe RH is known, m is not known. Okay, so if m is not known, so what is the value of m? How do I assume what's the value of m? What can be the values of m? That's the first question we need to ask. Now can m equal to 1 here? If I put m equal to 1, what will happen? It will be 1 by 4 minus 1. Okay, you are not aware, you have not learned anything theory about it, but still I am just putting across from the concept of data analysis point. Okay, you should know it from a general knowledge point of view. If I put m equal to 1, this will become 1 by 4 minus 1 will become minus 3 by 4h. Can lambda be negative? Length of a wave, can it be negative? Length of a wave cannot be negative, right? So therefore, m is outdated. M is not possible. Let us write down m not equal to 1. Can I put m equal to 2? If I put 2 over here, what do you get here? This becomes 0 over here. 1 by 4 minus 1 by 4 becomes 0 over here. When it becomes 0, 1 by lambda becomes 0, lambda becomes infinity. Can we have a wave whose lambda becomes infinity? It's not possible. Okay, why can lambda become infinity? Because you know, energy of a wave is given by, energy of a photon is given by hc by lambda. Okay, if 1 by lambda, so here when I say this becomes 0 over here, okay, let us take like this. Okay, if this becomes 0 over here, if I multiply this by hc, this also becomes 0. Can a photon have a 0 energy? Photon cannot have a 0 energy. You know why? Because it will have some energy, only then it can move with the speed of light, right? Any object will have some energy, only then it will possess some kinetic energy. When you say it has an energy equal to 0, you are going to make the photon to be at 0. That is not moving. Okay, so therefore, this is not possible. So you can say m not equal to 2. M not equal to 2. Now can I have m equal to 3? Definitely m equal to 3 is possible. If I put m equal to 3, what will happen? This will become, let me write down here, 1 by lambda 3 is equal to RH into 1 by 4 minus 1 by 9. Okay, so which should now be equal to RH into, so 9 ones are 9, 4 ones are 4 nines are 36. I just took the LCM and I got this as 9 minus 4 is 5. 5 RH divided by 36, or I can find lambda 3 is equal to 36 divided by 5 RH. I got this. Now I need to substitute this value and get. But the question now is not so much. Okay, we have found out for what value of m does this equation work. Okay, you cannot use these two. That's what the first thing that we have seen. The second thing that we have seen is we can use m equal to 3. Now the question is, can I put m equal to 4? You can use m equal to 4. If I put m equal to 4, what will happen? Okay, then this will become much more lower over here. Now what is the maximum value of m I can use? The maximum value of m I can use it is m equal to infinity. Let us do that also. Okay, because instead of testing lambda m equal to 4, m equal to 5 and so on, let us take the boundaries. Okay, the lower bound and the higher bound. The lower bound that I have used is m equal to 3, and the higher bound I am going to use it is lambda infinity, which means what? Now what do I get here? If I use this, let us try it out once again. 1 by lambda infinity is equal to RH into 1 by 4 minus 1 by infinity. What is 1 by infinity? 0. So this should be equal to RH by 4, which means I will get lambda infinity is equal to 4, lambda infinity is equal to 4 by RH. 4 by RH. Now here, what I will do is 36 by 5, how much will this be? Let us do 5 7s are 35, then you have a 10, 7.2 divided by RH. Now lambda 3 is equal to 7 by 2 times RH, while lambda infinity is equal to 4 by RH, which is the highest one. Whatever is the value of RH, okay, I'll substitute something, some constant value. So I can see lambda 3 is the highest one. Lambda 3 is highest. Any value which I put, okay, between 3 and infinity will definitely be lowest. So what should I do? I should just blindly take the value of lambda 3. See, I'm explaining the things, okay. Do not assume that in 2 minutes can I do all this. Okay, so you should know about it. That's why I'm just pulling across all this. So therefore, now I can write lambda 3. I can substitute the value, which is 7.2 divided by, what's the value of RH? 1.1 into 10 power 7. 1.1 into 10 to the power of 7, which will now be, let me use my calculator. 7.2 divided by 1.1 is equal to 6.54. 6.54 into 10 to the power of minus 7 meters. Okay, which will correspond to how much? Which may be around 654 nanometers. 654 nanometers. That is what they saw when they conducted the experiment. Then they found out for hydrogen gas that a red color line was seen. The first line was a red color line, which corresponds to 600 to 700 nanometers. Okay, next. This question is out of syllabus. I'm not going to do this one. Okay, for the current syllabus 2025, I'm not going to use this. Done. Okay, so with this we come to an end to this particular problem. We'll see the next problem in the next video. Thank you.